All right, guys, we are on to lesson 3.5, solving systems of equations. So by now you should have done lessons 3.1 through 4 and the mid-chapter quiz. If you haven't, please make sure you get that done. All right, so in 3.5, we were solving systems of equations. You have done this in Algebra 1. The only thing that is new is now we are going to do it with nonlinear equations. So what does that mean? Quadratic functions. So in Algebra 1, you learn systems of equations by graphing, by substitution, by elimination, using only linear systems. So now we're going to do it using nonlinear. All right, so what are some things that you need to know? Graphing is a great way, especially when you can use Desmos, to find your answer. When you graph them, you are looking for their points of intersection. So where do they cross? So for example, these two graphs do not have any intersection points, therefore they have no real solution. This one has one point of intersection, so it would have one real solution. And this one has 2 points of intersection, so it would have 2 real solutions. So this is when you have a linear and a nonlinear function. Now with this one, when we have 2 quadratic functions or 2 nonlinear functions, if they do not touch or cross at all, then they would have no real solution. If they cross or touch one time, they have one real solution, and if they intersect more than once, they intersect twice, you have 2 real solutions. Those points of intersections are your answers. All right, those are your answers. Now, how would you get an answer for this? So notice it says no real solution. So there may be an imaginary solution come in. So let's just get started. All right, we're going to start by solving this nonlinear function. Okay, so I was trying to get that straightened out. So we are going to graph these. All right, we are given a nonlinear and we are given a linear. So the linear one is going to be the easiest one to graph, so I'm going to start with this one first. So we know this is our y-intercept and this is our slope. So I'm going to grab my y-intercept first, so -1. And then my slope is -2, so that means I'm going to go down 2 and over 1. So your line should be decreasing. All right, I could also go backwards as well. So now I have this linear function. So this is the equation y equals -2x minus 1. All right, now we're going to graph this one. So we've learned a couple of things on how we can graph. We know right off the bat this is our y-intercept, and we can find the vertex by using our -b over 2a. So that's what I'm going to do down here. We're going to look for our vertex. All right, so we're going to do x is equal to -b over 2a. -b, so we got -2 over 2 times 1. And that gives us +2 over 2, which equals 1. So right now I know my vertex is 1 comma something. I just got to find that something. So how do I do that? Recall that we just plug in 1 into our equation. So y is equal to 1 squared minus 2 times 1 minus 1. All right, and so now we're just going to solve. So 1 squared is 1, -2 times 1 is -2, minus 1. So 1 minus 2 is -1, minus 1 is -2. I'm going to zoom out just a little. There we go. All right, so now we can graph this one. We know the vertex is 1, -2. We know it has a y-intercept of -1. So let's start with our vertex. We got 1, -2. So we're going to put that point there. We know that our y-intercept is -1, so based on my axis of symmetry, I know there is a point right there as well. Now, if you wanted to find more points, you could. All right, but it is not necessary for this because we can already see our point of intersection. So had we not been able to see our point of intersection, then I didn't mean to, then we could have moved on, or couldn't have moved on. So you would have needed to find more points. Again, as always, you have a graphing calculator, you have Desmos. If you get stuck on the graph, please put it in. All right, so here's the biggest problem that I noticed with lesson 3.1. So you guys do the graphing, the graph is there, but you don't give me the answer. So I need the solution. All right, you have to tell me what the solution is. So how do we find the solution? The solution is the intersection point. So our solution is this point right there. And what is that point? 0, -1 is that point right there. So that is your solution. If you have 2 points of intersection, then you would have 2 solutions. Solving by substitution. I even put some steps here just so you didn't have to write out a bunch of stuff. So when you're solving by substitution, you're going to solve one of the equations for y. Then you're going to substitute what that y equals into the other equation to solve for x. Then once you have that solved for x, you substitute your x value into one of the equations and solve for y. So let's do one step at a time. So I'm looking at these. This one looks the easiest and it's linear. To rewrite it for y. So how do I rewrite it? I can move the x to the other side, so it would be subtracted, so I could have y equals -x plus 4. Why did I write it like this? Because it's just a habit to be in slope-intercept form. All right, so we have this equal to y. So what step 2 is saying is that right here in this equation where there's a y, we are going to substitute what y equals. Okay, so I'm going to rewrite this. I've got x squared plus x minus. So now I'm going to put in parentheses -x plus 4 and then equals -1. And so now I am going to solve. All right, so we learned in lesson 3.2 that we need to distribute this negative. We also learned it in algebra, but we just kind of revisited it. So we got x squared plus x plus another x minus 4 equals -1. So now we want to combine our like terms and we want to set it equal to 0. So let's add 1 and we're also going to combine those together. So this becomes 0. We have x squared plus 2x minus 3 equals 0. So here comes one of your favorite F words. We got to factor it. So we need to know what are two numbers that when you multiply them, you get -3, but when you add them, you get +2. So if you said +3 and -1, you would be correct. So we've got x plus 3 and x minus 1. So this is lesson 3.1. If you need more work on this, just let me know. Now, how do we find the solutions? We have to set each factor equal to 0. So we got x plus 3 equals 0, x minus 1 equals 0, and solve. So if x plus 3 is equal to 0, then we know x is -3. X minus 1 is equal to 0, we know x is equal to +1. All right, so we have our x values. We solved for x. What is next? We're going to substitute those x values into one of the equations and solve for y. It doesn't matter which one. All right, I'm going with this one because this one, we got an easy x value and we already actually have it solved for y if you want to do it that way, but just for keeping it straight and simple purposes, I'm going to do it to this one. I mean, we could do that one too. It wouldn't be that hard. It's just more x's. All right, so I'm going to start with when x is equal to 3. All right, so -3 plus y equals 4. All right, so we add 3 to both sides and we get y equals 7. So when x is -3, y is 7. Now we're going to do the same thing, but for 1. So we got 1 plus y equals 4. So we need to subtract 1 from both sides. That gives us y equals 3. So when x is 1, y is 3. And guess what these are? These are your solutions. Okay? So that was substitution. The only difference between this substitution and Algebra 1 substitution is the quadratic function. That's the only difference. All right, we got one more type, and that is elimination. So our goal is to eliminate either your x or your y term. So let's look at what we could work with. Well, most of the time it's easiest to get rid of your y values because you're going to have an x squared, so it's going to be harder to get rid of the x squares and the x. So keep that in mind. You would have to get rid of both of them. So most of the time it is easiest to get rid of the y. I just put that because that's with any elimination. If it's linear, you could choose either one. All right, so we are eliminating our y values because if we treated this like an addition problem, that would give us 0, negative y, positive y. If it did not, remember you could multiply one of your equations by something that would make this happen. If you come across one of those on your practices and you want to look at it together, I would be happy to do that. All right, so we're going to add it like it's an addition problem. If there is none, there is one. So 2x squared plus x squared gives us 3x squared. Negative 5x plus 2x gives us negative 3x. And those cancel out, give us 0, equals negative 2 plus 0 gives us negative 2. All right, so remember we need to set our equation equal to 0, so we're going to move the negative 2 over there by adding it. So we end up with 3x squared minus 3x plus 2 equals 0. So we can look at this. What are two numbers that when you multiply them, you get 6, but when you add them, you get negative 3? If you're like, Ms. Gill, there are none, you are correct. So if all else fails in lesson 3.4, we learned that we can use the quadratic formula. So in this situation, we are going to use the quadratic formula. So I want you to pause the video now, plug in your values into the quadratic formula, and see what you get. All right, so I wrote the formula there just in case you forgot it. So if you work it out, you end up with x is equal to 3 plus or minus the square root of negative 15 over 6. Since our discriminant is negative, that means we have imaginary numbers. So because of those imaginary numbers, that means that we have no real solution. So remember, our imaginary answers are just so we can actually solve the problem. But in this case, we would have a situation where our graphs would look like this, something like this. So they would not touch each other. All right, so there would be no real solution. All right, so I wrote out in words, because the discriminant is negative, the equation has no real solution. So as always, in your practice, if you get to one of these elimination ones and you need to continue solving it and you need a little refresher, and the Chapter 3 Prepare isn't refreshing you enough, just let me know. We can work on just elimination or just substitution ones. Okay, so this last one, we are going to graph using technology. I'm going to teach you how to do it on the calculator for in the situations that you wouldn't have access to Desmos. I would like for you to use this in the classroom just to get more familiar with the calculator. So what we're going to do is we're going to take these two equations and we're going to set them up in our calculator. So we're going to do y equals 3x squared plus 5x minus 1, and then we're going to do y equals negative x squared plus 2x plus 1. All right, so in my calculator, I'm going to try to find not glaring parts. Oh, that didn't help. Give me a second. Type in those two equations. All right, so I have my two equations in there. I have my window just so if you're doing this set to negative 10 and 10. All right, so now our next button is to hit graph, and it is going to graph it for us. Now, remember, we are looking for our points of intersection, so we have two of them here. All right, so this is how I need you might want to write these steps down for the calculator, because yes, I am going to want you to try this. So we want to do the calc. So we need to do the blue button, then the calc. And we're looking for the point of intersection. So I'm going to scroll down to 5. So blue button, calc, and number 5, and hit enter. All right, notice it says first curve. So I'm going to move my button to over here, and I'm going to hit enter. Now it says second curve. So I'm going to, I want it on the blue one. I'm going to move it to the right, and I just really need it on each side of the intersection. And then I'm going to hit enter. Enter. Okay. Why are you not liking me? Maybe it wants the red one after all. Enter. Okay. And then it says guess. So we're going to hit enter. So it is giving me this intersection point instead of that one, but that's okay. We'll get that one. So it's giving me this intersection point. It's telling me this is my X value and that is my Y value. So we are going to round. We'll go 3 decimal places, so thousandths place. So write that ordered pair down. All right, so intersection points. So here's one of our intersection points. Sorry, I don't know why this is looking. So this one I had to round to hundredths place just because that was a 9. The 9 goes to 7. That becomes 0. So now we want to do the same thing, but we want to get the other one. Hopefully it will work for me this time. So we're going to hit the blue button, then calculate. We're going to go down to 5, and we need this side. So enter. I'm going to leave it right there, enter, and it says guess, and you hit enter, and now it has told me that this intersection right here is this point. So again, we're going to round 3 decimal places. So your solutions for this are just your X values. So, well, sorry, I'm beating up the camera. So X is approximately negative 1.175 and X is approximately 0.425. All right, so we're going to do the same thing to this one. And give it a try and see if you've got it. Going to do the same thing we did before. We're going to hit the blue button and calculate. We're going to go down to intersect, hit enter. We're going to go to the left side of that intersection point, hit enter, and then go to the right side of the intersection point, hit enter. It says guess. We're going to say yes, enter. Oh, Miss Gill. All right, I'll be right back. Okay, for some reason that was not wanting to work, so I'm going to zoom in. I'm going to change my window slightly because it looks like they're crossing right there. So I'm going to change my window to, I want my Y minimum to be -1 and see what happens. Okay, so yes, you can do this as well. I zoomed in. I can see that they are clearly crossing right there at the origin 0, 0, which is the answer. I don't know why this one was being such a pain in the butt. But again, so if you're in class, you're working on this, you need some help with the calculator, come see me. I will help you with the calculator. So our intersection point is 0, 0, so that means that X is equal to 0. All right. Hopefully you don't find this one too bad. I know it's not everybody's favorite because not everybody likes systems of equations, but again, please seek my help if you need it. All right, I will see you in class.